All right, this is still from page 185. My computer died, so I had to do a second video. So we're given this point and this equation. So the first thing we want to identify is this is the slope. Slope -3/5. All right, so we want the perpendicular slope. So perpendicular slope, this is negative, it's not going to be positive down here. And then flip over the fraction, so 5/3. So that's the perpendicular slope. We're now going to plug into this. And then I'm going to plug my values in. So this is my x value, this is my y value. Remember, when I plug them in, it's opposite value. So it was a +1 here, it's now a -1 down here. I'm going to use the perpendicular slope, because we want the perpendicular line. Then x minus 6. It was +6, now it's to -6. So here's my equation that is perpendicular to this, and it also contains this point. Okay, so let's take a look at number 7. It says we want both the parallel and the perpendicular. Okay, so let's take a look. So I'm gonna draw the best I can the graph that they have in the book. So this looks like it's up at 6. And if I go down 3 and right 1, there's a second point. So we have, here's our line. And then we have the point 4, 2. So 1, 2, 3, 4. So 4, 2. 4, 2 is like here. This is the point they gave us. So the first one we want to do is let's figure out the slope of this line. If you count on your thing, this starts up at, oh, this is actually 5. And we went down 1, 2, 3. So if I go down 3, 1, 2, 3, and right 1, so down 3, so that'll be a -3, and right 1, this is my slope. So my parallel slope is going to be -3/1. I'm going to use this point. This is x1, y1. So to find the line that is parallel to this given one, and it goes through that point, will be y minus y1 equals m times x minus x1. So opposite values plug in. So it's a +2. Now it's a -2. Then I plug in -3/1, or you could just plug -3 in. And then I'm going to go x. My x value is +4, so it's now -4. So this is our parallel line to this, meaning it would go right along here. So the parallel line would look kind of like that. And then now I want to find the perpendicular. So the perpendicular slope. So if I want the perpendicular slope to that, if I want to make it perpendicular, I'm going to change it from negative to positive and flip the fraction over just to get 1/3. Then I'm going to go ahead and use my equation again. So remember, my y value was +2 here, so it's -2 here. My slope is 1/3. My x value is 4, +4, so it's -4 here. So this is our perpendicular, meaning it's basically going to look like this if I had graphed it. And I know it doesn't ask you to graph it. I'm just trying to show you the representation. Number 8, again, I'll try and draw this picture best I can. So let's see. It looks like at -2, 1, I could see that point, and then maybe 2, 2. It's up here. So this is our line. And then we have the point 2, -2. That's given. So again, we want to find the parallel and the perpendicular. First thing I want to do is let's figure out the slope of this line. So if I'm going to go up 1, 2, 3, 4, so up 4 and right 1, so 4/1, so it means our parallel slope has to be 4/1. Let's go ahead and plug in our equation. So we know that's x1 and y1. So y1 is -2, and it's now +2 down here. My parallel is 4/1, or you could just make it 4. My x1 is +2, so it'll be a -2 here. So this equation is parallel. So again, it would look something like this, not as wavy. My perpendicular slope, so if I want the perpendicular slope, this slope was positive, so I'm going to make it negative. Flip it over, 1 over 4. There's our equation, or there's our perpendicular slope. Go ahead and plug back into this. So my y1 is negative 2, so it'll be positive 2 here. My slope is now going to be negative 1/4. My x1 is positive 2, so I'll be in negative 2 here. So basically, this perpendicular line would look something like this. And again, didn't ask you to graph it, but this is our perpendicular equation. So number 11, they want to know, is a line, we want to say if it's sometimes going to happen, always going to happen, or never true. A line with a positive slope and a line with a negative slope are parallel, and that would be never. Okay, you can't have a positive slope and a negative slope to make parallel. Okay, that just doesn't work. Number 12, a vertical line is perpendicular to the x-axis. So let's think. A vertical line, this would be a vertical line. Yep, it is perpendicular. Yes, this is always true. Always true. And then number 13, two lines with the exact same x-intercept are perpendicular. This is only sometimes. So you could have, let's say you have an x-intercept and you drew a line like this. So I could draw that and that. Those are just two crossing lines. But I could also draw it like this. I could draw a line like this and a line like this. Would that be 90? So that's only sometimes going to happen. So sometimes. Okay, so your assignment is going to be a review. There will be a video tonight because we have a quiz on Friday. So what we'll do is we're going to work on page 187 and 188 during class. I will have a third video posted that will go over it, so you make sure you can have a review because we have a quiz on Friday. Okay? I hope you guys have a nice day. Take care of one another. Bye-bye.